we all agree that when you're doing, like when you're like dropping a yo-yo up and down, it's a sine function. Like when it's at the bottom, well, here's your, oh boy, here's your hand. That's our hand. Here's our yo-yo. Here's the ground, right? So you drop the yo-yo, and when it's at a minimum, that means its height off the ground is the smallest, and then it goes back up, and then when the yo-yo is kind of at your hand, it's got a maximum height off the ground, and then it's going to go back down to a minimum height off the ground, right? And then it's going to come back up, and this just goes over and over again. So they tell us that the height of a yo-yo above the ground, then that's your y-axis. Height of yo-yo above the ground can be well modeled using the equation, and they're actually giving us the equation where h represents the height of the yo-yo in feet above the ground. And here's very important, because this is going to tell us, are we starting at a midline, are we starting at a maximum, are we starting at a minimum? T represents the time in seconds since the yo-yo was first dropped from the maximum height. So where's our graph going to start? At a minimum, a maximum, or a midline? Maximum. Think about when you start dropping a yo-yo. Your yo-yo starts in your hand, and then you drop it, right? And your clock starts. So time since maximum. So it's going to be a positive cosine graph. That tells me it's starting at a maximum. So, a little bit different here because we're given the equation, yes? What details from this equation can we grab? What is the maximum height? Take a minute, raise your hand when you can tell me what is the maximum height. What do you think, Morgan? Where'd you get 4 from? Oh, so you just use your calculator. Okay, why not? Okay, and logically, why would you add those two? She's correct. It is 4. Because this is the what? Midline, and then 1.75 says you're going to go 1.75 above the midline. That would be the addition. 2.25 plus 1.75 gives you 4. So I'm going to write midline plus amplitude, so we can kind of remember where this came from, equals 4. And then the minimum is going to be your midline minus your amplitude. So 2.25 minus 1.75 is a half. So with that information, I think I can now scale my graph. I want it only needs to go up to 4. So I'm going to count every other as being 1, 2, 3, and 4. And right now I'm starting on a maximum of 4. That I know. And I'm also going to end on a maximum. The issue is I don't know where that end point is going to be yet. But what would I find to figure that out? If this is where my first maximum is, what do I need to calculate to find out where my next maximum is going to end? I heard someone say it. The period, exactly. Maximum to maximum is a period, and so we can calculate our period by doing 2 pi over b. And this is different because we actually already know b just by looking at the equation. What's our b value? What's in the place of where our b normally is? Pi. So 2 pi over pi tells us our period is 2 seconds. Okay? Now, I'm not going to jam an entire cycle in 2 seconds and count by ones. I'm actually going to count by like 4s. 1, 2, 3, 4 is going to be 1 second. 1, 2, 3, 4 will be my second. That way I can really spread it out. So if I'm at a maximum at the 0 second mark, I'm going to be at a maximum again at the end of that period at the 2 second mark. So when am I going to be at my minimum? Eric? When? So at what time will I hit the minimum? It's not going to tell you. You kind of have to look and think about what we've done so far. We're at a maximum at 0 seconds, and we're again at a maximum at 2 seconds. So where must we have hit the minimum? Like right here? Everything should be pretty, everything should be pretty symmetrical. So we're going to hit the minimum at 1 second, and what was our minimum, did we say in part B, Eric? A half of a foot. Is it a foot or an inch? Does it say? H represents the height. It doesn't say, I'm assuming it's a foot. So at 1 second, we're at a half of a foot. Where's my midline? What's halfway between a half and 4? Well, average them together. 4 plus a half. Oops. Delete. And divide it by 2. So the average is 2.25. Duh. You guys. So you're 2.25, which is going to be somewhat difficult to graph because it's not exactly at a currently existing line, but there's your midline. And so if our maximum was at, look up at the board here, if your maximum's at the 0 second mark and your minimum's at the 1 second mark, when will we cross the midline? Since this is all very evenly spaced. Chris Brooks? At what time, when I connect this point with this point, at what time am I going to cross the midline? Over here? When I'm connecting this point to this point? A half. Your critical points are happening every half of a second. So we cross the midline, then a half of a second later we're at a minimum. Then a half of a second later on the way back up, we're going to cross the midline again. And then once you have your 5 critical points, give a nice curve that mimics that trig relationship there. Okay, graphically determine all the times. That's okay. Graphically determine all the times during the first cycle, and that's great because we're only looking at the first cycle. This is kind of like that tanker follow-up question, when the height of the yo-yo was exactly 3 feet. It's just not an inequality. When was it exactly 3 feet? So we're going to plot that on our calculator, and we're also going to plot 3 feet exactly, and we're going to figure out when did that happen and when did that happen. So on my calculator, typing in my 1.75 cosine of pi x plus 2.25, and then y equals 3. Setting your window accordingly. My window is currently set up right now for the tanker question. We have very different times that we're dealing with. We're not dealing with 24 hours anymore. We're dealing with 2 seconds. So 0 seconds to 2 seconds. We're not dealing with depths of water that are like 40 feet. We're dealing with heights of yo-yos, so 0 to 5 makes sense. So graph that cosine function. There it is, with a nice window, so I see it pretty well. There's my height of 3. It's, of course, it's going to cross 3 feet on its way down. Second trace intersect will tell us when that occurred. Point, does it say to round? No, we'll go to the nearest 10th. 0.4 seconds in. So 0.4 seconds. And it's going to happen again on its way back up. So second trace intersect, scroll me way over here. .6. So on the way down and on the way up. Can you pass those up? So Bella's going to pass out your trig tests. Then obviously not the trig graphing tests because that's not happened yet. This is your trig test. Your corrections will be due on Wednesday. Okay, yeah, that's fine. Your homework for tonight is to finish this worksheet. These two on the front, and then the two on the back. Okie doke. Take your time with it. Make sure your graphs are accurate.